Okay, a truck has twice as much mass as a car that collides with it, which the following statements are true. Whichever one says that the forces are the same. Twice as much force, no. Half as much force, no. Okay. Well, no, so the accelerations are different because the truck, the forces that they feel are the same, right? So the force of the truck equals the force of the car,
Right.
but the mass
is heavier. So.
yeah. So if I say that the mass of the car is equal to m, then that means that the mass of the truck is equal to 2m. So that means, like, on this side, I would have to have 2m times something equals m times something, right? Like, so if I put in an a here, I have to put in a 2a there for that to work. You know what I mean?
Oh, okay.
I suppose you could do it like that.
So that's
So
the
the car,
acceleration of the car is double that of the truck.
yeah.
That's cool.
Okay, what physical quantity corresponds to the effect that is observed as a direct result of an what? What physical quantity corresponds to the effect that is observed as a direct result of an object is pushed?
I know. That's like.
I mean,
this test
I don't know. When an object is, I think when an object is pushed, it feels a force and therefore it accelerates. I don't know.
Yep.
Whatever. That's the worst question possible because it does all of these things. Like, it has mass, it picks up velocity, the push is a force, and it goes somewhere. It's the worst possible question. An astronaut on the moon measures their weight. I'll do a different color. And finds that they weigh about 6 times less than when they're on Earth. What is the best conclusion that can be drawn from this? The astronaut has 6 times more mass on the moon than on Earth? No. Has 6 times less mass? No. It's got the same. The astronaut has the same mass on the moon as on Earth, but like, that's not the conclusion that you draw from this, right? Like, yes, the astronaut does have the same mass on the moon and the Earth, but like, based on his experimental findings, that wouldn't be the like conclusion.
Okay.
You wouldn't be like, oh, I weigh less, therefore I must have the same mass.
Right, okay.
Does that make sense? Right. Like, even though this statement is true, like, this is a true statement, but it's not the answer because that's not the conclusion you would draw from it. So then the acceleration of gravity on the moon is 6 times more than on the Earth? No, the acceleration of gravity on the moon is 6 times less than Earth. Yeah.
Right, I think that's right.
Does that make sense?
Yeah.
Because weight, or the force due to gravity, is mass times gravity. Yeah, and it's the same. This number is the same, or no, this number is 6 times less on the moon, and the mass is the same. Therefore, the acceleration due to gravity has got to be less.